All right, onward and upward. Now we're moving on to 7.4, which is about solving polynomial equations. So we've practiced the last 3 units learning how to factor them. Now we're going to start figuring out how to solve them, which is really just going to be one extra step. We're going to say it equals something, and then we need to figure out what x actually equals. So before we were just splitting it into the 2 parentheses. Now that we're going to put an equal sign and something else on the other side, our answer now, instead of those 2 things in parentheses, is going to be x equals something. Most of the time it's going to be 2 numbers that we're going to be finding what it equals. Since it's squared, that means that I could have like -4 or +4. They both squared would be 16. So usually we're going to have 2 answers. Sometimes we'll only have 1. Sometimes we might have no solutions. Sometimes we might have infinite solutions. But 2 answers almost always is going to get you to where you need to be. So you're looking for 2 answers most of the time. Before we start learning how to solve in factored form, you guys have a warm-up problem, which are not polynomials, just to make sure you remember how to solve. So this would be a good time to pause me, make sure that you know how to solve linear equations, which means there's no squared value on it. We don't have to worry about that yet. Make sure you can do that. Then we will start learning about what do we do when it's squared. So, or when there's multiple x's. So solve these, pause me. Hopefully you paused me, I took a little break there. Yeah, let's really quick go through the answers on these. Hopefully you remember how to do all of this stuff because it's old. The first problem, we subtract 4 on both sides and get -13. The second one, you have to multiply each side by 3/4. So if you don't remember how to multiply fractions, let's really quick go over that. If I want to get rid of 4/3, that means I multiply by 3/4. -8 times 3/4. I'm not worried about that because I have a great math teacher who taught me a trick. You just go in a loop, you divide on the bottom, you multiply on the top. 8 divided by 4 is 2, times 3 is 6. Since 8 is negative and 3/4 is positive, that means a negative times a positive. My answer is -6. So the answer to number 2 should be -6. The answer to number 3, same thing. We're multiplying both sides by 2 to get rid of that 1/2. -16 times 2 is -32. On 4, we're just adding 2 to both sides. That's 27. 5, we're multiplying both sides by 3 to get 33. 6, we're adding 4 to get 12. So hopefully we were able to do most of those. If you didn't get number 2 right or you had to ask for help, I'll forgive you this time. But we really got to get fractions down. They're just numbers. A fraction just means you divide and multiply instead of just one or the other. You can do that. I know you can. That was kind of an abrupt stop. Sorry, I usually don't record myself teaching, you know. All right. So let's start learning. Okay. So, this problem tells me solve each equation, and now I have 2 things, which is a little bit scary. We've never done that before. Usually we just have something like 3x equals 0, or x minus 6 equals 0. That's what we're used to. Now, how am I supposed to figure out what 2 numbers multiply times each other to get 0? Well, actually, it's really not that big of a deal because I know that as long as this is 0, this could be anything in the world, right? It could be times 5, it still equals 0. It could be times 4, it still equals 0. It could be times 8, it still equals 0. It could be times pi, it still be 0. It doesn't matter what the second term is as long as the first term is 0. So this is actually enough to give me one of my solutions. As long as this is 0, I can multiply by anything I want and the whole thing will be 0, right? 0 times anything is 0. That's what this is saying. As long as I can get this first term to be 0, I'm golden. Well, same thing about the second. If I made the second term equal to 0, I could have the first term be whatever I want. It could be 3, it could be 7, it could be pi again, it could be a fraction. It doesn't matter what the first term is, as long as the second term is 0, I would also have an answer. 0 equals 0. This could be anything I want. So actually, this is enough to get me my second answer. So hopefully you remember a few minutes ago I said there's going to usually be 2 answers to these types of problems. Well, that's because I have 2 options to make this equal 0. My first term can be 0, or my second term can be 0. It doesn't matter which one, as long as one of them is 0. When we multiply, the whole thing is going to be 0. So let's solve these, plug them in, make sure that we're not being crazy. If 3x equals 0, I'm going to solve for x by dividing both sides by 3. X equals 0. So there's one of my answers. I know I'm done because x equals a number. I don't have to do any more work. Over here, we just did this in the warm-up. We get rid of minus 6 by adding 6. X equals 0 plus 6. That's 6. So there's my second answer. So I have two answers that I think should work in here. X can equal 0 or it can equal 6. And I'm going to really quick plug this in to make sure that's true. If I plug in 0, I get 3 times 0 times negative 6. 3 times 0 is 0. 0 times negative 6 is 0. Yeah, that one worked. Same thing with 6. 3 times 6 is 18. But 6 minus 6 is 0. So what I end up getting here is 18 times 0. Well, as we just yammered about for a long time, that equals 0. As long as one of the terms is 0, when we multiply, they both will be. So that's my answer. If you want to try B on your own and kind of tune me out for a second, you can sure go for it. If you want to see another problem done, though, that's okay. So what we just talked about is as long as one of the terms is 0, I don't care what the other one is because 0 times anything is going to give me 0 as my answer, which means that x plus 5 can equal 0, or, because there's pretty much always going to be two answers, x minus 4 can also equal 0. Here's my two ways I can get 0 as my answer. I'm going to solve them. X equals negative 5. X equals 4. So down here, I'm going to say x can be negative 5 or 4. See here, I put a comma, and here I put or. They mean the same thing. Okay, both of these would work, both of these would work. So that is how you solve in factored form. Before we move on to some other solving problems, I have 3 problems I want you to try on your own. See if you can separate these into the 2 different options you have and solve. Solve these 3 problems. They should all have 2 distinct answers. You can pause me, do these problems, and we'll check our answers in a second. Okay, so hopefully you've solved them. The first one, x equals 0, that one already is solved for me, and then x equals 1 should be your 2 answers. The second one, 3t equals 0 would give you 0, t minus 2 would give you, or t plus 2 would give you negative 2 as your answer. The third one, you should get 4 and 6. Did you get them right? Hopefully you did. If you didn't, maybe we can do the thumbs up. If you got them right, thumbs down if you need a little bit of help. We can decide if we need to pause as a class or if we're ready to move on. All right, so I'm going to pull this a little bit closer to me so you can really see what's going on. Sorry, I will probably look crazy. Okay, so these problems are extremely similar, except now we also have a coefficient out front. Well, we're not worried about that. We already know how to solve this. 2x plus 7 equals 0. 2x minus 7 equals 0. Both of these are options, so I'm going to solve both of them. I'm going to subtract 7. 2x equals negative 7. Divide both sides by 2. I don't know how many times 2 goes into 7. Well, I do, but maybe you don't, which means that's fine. You can just leave that as the answer. If it's not divisible, you can leave your answer as negative 7 halves. Or if you want to change it to a fraction or into a decimal, that would be negative 3.5. These are the same thing. Okay. In the other one, I'm going to do the same idea, plus 7, 2x equals 7, divide by 2, divide by 2, x equals 7 halves, or 3.5 positive version. Okay, this is not 4 answers, because these are the exact same thing, these are the same thing. I have two factors, 1, 2, so I have two answers. They're really similar. This one's just negative and this one's positive, which makes sense because look at the factors that we have. This one's positive and this one's negative. So the only difference between these are the signs. The only difference between my solution is my signs. Okay. B, x minus 1 squared equals 0. Well, I know that squared just means it's the same thing twice. So these are going to obviously solve to be the same thing since I'm writing the exact same thing twice, but just so we can see it visually, this is what the first step would be. Then I'm just going to solve one of them because I can already tell it's going to be the exact same thing. Add 1 to both sides, and I get x equals 1. And it equals 1 again. So instead of saying x equals 1 and then writing that out on there twice, I would say that it has repeated roots. I'm just going to write in here twice. Okay. Graphically, if you're wondering, what this would mean is that if I were to graph this equation, it would go through at 1, 2 times, which would make it bounce on the number. Something like this one over here, if I were to graph this, I would have a point on the negative and a point on the positive, so my graph would look like that. I don't know if you can really see, but it goes through each of them one time. This one technically goes through the same point twice, goes through it going down, and then goes through it going back up. So if you take pre-calc or something like this, how you're going to say this is 1m2, which means that there are multiple solutions that come out to be 1. There are 2 of them. But I'm fine with you saying x equals 1 and then letting me know that it happened twice. So you can say repeated roots. You can say x equals 1 multiplicity of 2. You can say 1 twice. You can say 1 bounce. We'll talk about that eventually when we get to graphing. There are lots of different options, but I want you to somehow indicate to me, I know there's only one answer, but really there are 2. It's just the same answer twice. Probabilists should always have 2 answers to them. All right, C, this is a little bit different because now I have 3 problems. Well, this actually isn't a parabola, it's a cubic, because if I were to multiply x, 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 I get x to the 3rd power. So this is actually a little bit different than most of what we've been doing so far. The graph would look more like that than it would like a U. Looks like that. But I can still solve it. So since there are 3 factors this time, I'm probably going to have 3 solutions. X plus 1 equals 0, x minus 3 equals 0, and x minus 2 equals 0. Well, I can solve all of these really easily. None of them even have a coefficient in front of them. The first one should give me x equals -1, since I subtract 1 on both sides. The next one will give me x equals 3, since I add 3 on both sides. And the last one will give me x equals 2, since I add 2 on both sides. So those are my answers to the 3rd one. Okay, so now I'm going to have you guys try some on your own. Maybe you're getting wise to the process. So you have a couple problems that you want to try on your own. If you need to ask for a little bit of help from a neighbor, that's okay. But your goal is that you are tracking along well enough in this lesson that you can do these problems by yourself. Okay? So pause me. We'll go over the answer in a second. All right, hopefully you paused me. So let's go over these answers. You're just solving each of the factors separately. The first one comes out to be -3/5 and -8/5. Don't forget your negatives. B, the book is actually just saying it equals -7. They're not even making you put a multiplicity, but I'm going to make you do that because it'll matter for graphing. It'll help you in the long run. So B, according to what I just said, you should be saying -7 twice or something like that, or -7 M2, -7 bounce. Lots of different options there. Make sure you let me know if this has a repeated root though. And the last one will have 3 answers, which are 2, -6, and -8. Okay. So we're going to move on to something a little bit different now. This is in the solving section, but it's actually just going back to factoring. So the first time that you learned the word factor, it was because you were learning about things that multiply to create other things. So for instance, 9 is a factor of 45 and of 36 because 9 goes into both of those evenly. So if I'm being asked to factor something that I can't see what those two parentheses things are going to be, that's okay. I can just look at both of these and decide what do they have in common. Sorry. So I'm going to look at the numbers and I'm going to look at the letters. So 4 and 24, they both have a number in common. What factor goes into 4 and 24? Excuse me. Well, 4 goes into both of them. So I'm going to factor out 4 from both of these problems. When I do that, 4 divided by 4, because factors mean multiply, so if I want to take it out, I'm going to divide. 4 divided by 4 is 1. 24 divided by 4 is 6. I'm leaving space because I haven't done anything with the x's yet. So I got some x's to fill in here. So that's the numbers. I just got rid of this 4 and this 24. I'm going to cross them off so I don't accidentally do it twice. Now I have x to the 4th and x to the 3rd. Well, how many x's do these have in common? This one has 4, this one has 3. So how many could I take out and still be safe? Well, it's not about how much these go into, as we learned from the last chapter. Exponents already mean multiply, so I don't have to look for a common factor here. This means x times x times x times x. This means x times x times x. So they have 3 x's in common. If I take out 3 x's, that's saying x to the 4th divided by x to the 3rd. We learned in the last chapter that means subtract. X to the 3rd, or x to the 4th divided by x to the 3rd is just x. This is all about division. We're not actually subtracting, we're just using our exponent rules we learned in the last chapter. X to the 3rd divided by x to the 3rd is 1. Right, that all the x's go away. We took out all the x's from the second one. So I'm not going to put anything here because all the x's got taken out, right? There's 3 x's in here. I took all 3 out. I'm not going to put anything here. So I got rid of these. These are already taken care of. I'm factoring it out. So what this is saying is that when I divide 4x to the 4th plus 24x cubed by 4x cubed, I get 1x plus 6. Okay, this looks a little sloppy, so I'm going to rewrite it for my final answer as 4x to the 3rd times 6x plus 6. That's my answer. And I can check to make sure I did this right really easily by just multiplying it back in. Factoring means you're dividing something out. You're trying to get it. You're trying to pull out through division whatever they have in common. If I wanted to check that I did it right, I could multiply. 4x to the 3rd times x would give me 4x to the 4th. X to the 3rd, an extra x, you end up with 4x's being multiplied. 6 times 4x cubed is 24x cubed. Well, that's good that I got this answer because that's exactly what I started with, so this is the right answer. So that's probably worth it. That took me a couple seconds only, and now I know I'm going to get 100% on that problem. That's probably a worthwhile idea for you to also follow. Yeah. Let's do one more of those. 12x cubed plus 3x squared. I'm going to do the exact same thing I just did, but I'm going to do another one with you so that you don't feel overwhelmed. So 12 and 3. What numbers go into 12 and 3? The biggest one that goes into both of them is 3. So I'm going to take out 3 from the numbers. Well, when I take out 3 from 12, factor means division. 12 divided by 3 is 4. 3 divided by 3 is 1. I don't actually ever have to write 1 since this is all about multiplication, but I'm going to write it just in case something crazy happens on the next one. So now I'm going to do the x's. This has 2 x's being multiplied. This has 3 x's being multiplied, which means I can take out 2 of them from each equation. X cubed divided by x squared leaves me with x. X squared divided by x squared, well, anything divided by itself is just 1. So I'm not going to have any x's here. I only had 2. I divided both of them out, so I don't have any x's left. I'm not even going to write it. And that's my answer. 3x squared times the quantity of 4x plus 1. And again, I'm going to spend the extra 5 seconds checking my work because I like to get good scores on my tests. 3x squared times 4x would be 12x to the third. Check. I got that one right. 3x squared times 1, oh, that's super easy. Multiplying by 1 just gives me the same thing. 3x squared. Same answer. All right, so now you have another one for you to try on your own. See if you can do this on your own. Pause me probably for a second here. All right, hopefully you paused me. 8 and 24 are both divisible by 8. Y squared and y are both divisible by y. When I take out 8y from 8y squared, I'm just left with y. When I take out 8y from 24y, I'm just left with minus 6. Then I can check my answer. 8y times y is 8y squared. Check. Negative 6 times 8y is negative... Ooh, good thing I checked my answer because that's not true. This should be 3. 8y times negative 3 is negative 24y. If I was here today and someone called me out on that, I would give you extra credit. So maybe you missed Funstein if you just heard a bunch of people in shock. Whoever was the most shocked, you could just write their name down. I'll give them an extra credit point. So this is your answer. Good thing I spent the time to check it because now I know that I got the right answer. There it is, 8y times the quantity of y minus 3. Why didn't I check my answer using that instead of getting the wrong answer? Nobody knows. Now you guys know that I'm actually doing this math. No cheats. Okay. So, the reason that we just learned how to do that is because we can take something that's not factors, it's just a polynomial, 2 totally separate terms, and turn it into factors, meaning that they're being multiplied times each other. Factors have to do with multiplication and division. If there's a sign in between these that says plus or minus, they're not factors yet. Over here we have a minus sign. We cannot solve this, but here we can. Because what we just learned is when we're multiplying 2 things, as long as one of them is 0, then the whole thing would become 0. So on the next problem that we see, which says to solve, oh, wrong one. Here we go. Solve 2x squared plus 8x equals 0 and 6n squared plus 15n, or 6n squared equals 15n. They're 2 separate problems, but we're going to put everything we've learned so far in this lesson together on this problem, okay? So, I cannot solve this because it is not factored. I don't know anything special about how to make things equal 0 when they're added. I only know about multiplication. So I'm going to turn this into factors by pulling out what they have in common. Then I'm going to solve it. So we're going to use both of the things that I've been talking about for the last while and put it all together. Okay, first thing is that I'm going to factor this. I'm going to take out what they have in common. 2 and 8 are both divisible by 2. X squared and x are both divisible by x. Now I'm going to put what's left over inside. 2x squared divided by 2x leaves me just with a sole little x. 8x divided by 2x, well, 8 divided by 2 is 4, and the x's are going to go away, plus 4. Well, it tells me already it equals 0. They're being nice to us. They always make it equal 0. That's very sweet of them. And now I am going to try to solve this. Well, what we learned earlier is that when you have 2 things being multiplied, either one of them can be 0 and you're good to go. I factored it, which means now I can solve them both. Equals equal to 0. The first one, when I divide both sides by 2, I get 0. The second one, when I subtract 4 from each side, I get negative 4. X equals 0 or negative 4. Okay, B. Uh-oh, this one has stuff on both sides of the equal sign. We haven't had to deal with that yet. We've always been making it equal 0, which is actually not that big of a deal because I can easily just make this equal 0. All I need to do is move 15n to this side. So the first thing I'm going to do on this one is subtract 15n from both sides. The reason I'm doing that is so that this side can equal 0. I like when it equals 0 because then I can do this process. You can only do this if it equals 0. 0 is the only number that follows this trick that whatever you multiply it by, it always stays the same. 6n squared minus 15n equals 0. Nice. One extra step. Now I'm going to solve this. I'm just realizing how stupid I'm making myself sound, and I'm not even here to defend myself. Okay, so 6 and 15. Everyone shout it at me. Maybe I can hear you all the way from Colorado. What do 6 and 15 both have in common? Well, they're both divisible by 3. So I'm going to divide both of these by 3. N squared and n. How many n's do those have in common? 1 n. So I'm going to put 1 n out here. Now I'm going to actually do my division problem. 6n squared divided by 3n would give me 2n. Negative 15n divided by 3n, negative 15 divided by 3 is negative 5, and the n's go away from each other. Now that I have factors, I can solve. I can't solve it when it's written like this. There's no factors. You have to have your 2 factors. Now I do have 2 factors, so I can solve. 3n equals 0, and 2n minus 5 equals 0. 3n equals 0, that gives me 0 as one of my answers. 2n minus 5 equals 0 gives me 2n equals 5, which gives me an answer of 5 halves, or 2.5. I'm writing this one underneath it so that you know there's not 3 answers. These are just the same thing. I don't care which one you like. If you like fractions, leave it as 5 halves. If you like decimals, you can do 2.5 as your answer. Either one is good with me. Okay, so thumbs up if that made sense. If you want to feel ready to try some on your own. Thumbs down if you need a little bit of help. Maybe I can get paused really quick and someone in the room can help explain what the heck is going on. Okay, hopefully you paused me if you needed it. So next thing you guys are going to do is try a couple of these on your own. So we're going to see if you can put it all together. Can you factor and solve? Can you get these to become multiplication problems by dividing out what they have in common and then set them equal to 0? Okay, so pause me, try them on your own, and we'll come back together in a second to go over the answers. Okay. Hopefully you paused me. The solutions for the first one should be 0 and negative 5. The solutions to the second one should be 0 and 3. And the solutions to the third one should be 0 and 1/2. So if you weren't able to get those solutions, my guess is probably that you struggled with the factoring process. If you need a couple seconds to talk with a person around you about how you got these answers, if someone's confused now that you're seeing them, or if you want to see one of them worked out, you guys probably know by now the people that would feel comfortable showing you those things. Please take advantage of them and their genius and let it soak into you. So pause me if you need a second. All right. I think I'm just gonna be done. Yeah, all right, so that was 7.4, solving factored problems. So we were able to learn 2 main concepts. One is that when you have 2 things being multiplied times each other, you can break them apart and solve them both as long as it equals 0. That was the first thing that we learned. The second thing that we learned is that when I have 2 terms that aren't being multiplied, if there's an addition or a subtraction sign in there, I can take out what they have in common and create factors. Then I can set those equal to 0 and actually get a real answer. So those are the two things we learned in this chapter, or this section. We have one more section that we need to go through today, and then you guys can spend the rest of the time working on homework.